Hi, my name is Sarah, and I'm doing number 61 in chapter 26. The problem asks to find the E field at points 1, 2, and 3 in component form. And so this is the layout. It's 0.03 meters to point 1, 0.04 meters to point 3, and using the Pythagorean theorem, I found that it's 0.05 meters to point 2. So let's start with point 1 using a kind of form of Coulomb's law, or the electric field equation, which is E equals K Q source charge over R squared, which is the same as 9 times 10 to the 9th. And then source charge should be in coulombs, so it's 10 times 10 to the negative 9th all over 0.03 squared. If you put that in your calculator, you get 100,000 J hat, because it's only in the y direction and you have no I hat, Newton per coulomb. And for point 2, well, we'll get to point 2. Let's do point 3 first. We'll do the same thing. E equals 9 times 10 to the 9th times 10 times 10 to the negative 9th. This time it's 0.04 squared. So we should get a smaller number since it's farther away, and we do. We get 56,250, but using sig figs, we'll round that to 5.6 times 10 to the 4 newtons per coulomb. Okay, so we have found the charge. Oh, and this one is going to be I hat because it's only in the x direction and you have no y components. And now point 2 is a little bit trickier because you have x and y components. So let's try that one. And point 2, since we know it's 0.5, let's go ahead and find the total charge. And that comes out to 36,000 newtons per coulomb. Okay, so now we have to figure out the components. And if you draw this out again, 0.03, 0.04, using trig, you find this to be 36.9 degrees, and that's just using sine, plugging it in. And this is 0.05. Okay, so let's use the component. And 36,000, which is right here, times sine 36.9 degrees. And that gives you 21,615.1 newtons per coulomb in the x or the y direction, so that's going to be J hat. And if we do the x direction, cosine this time 36.9, and for that we'll get 28,788.6 in the x direction. And so to put that into component form, we'll get E at point 2 equals 2.2 times 10 to the, what am I saying? To the 4th, J hat plus 2.9 times 10 to the 4th I hat, and we should probably switch that. So equals 2.9 times 10 to the 4th I hat plus 2.2 times 10 to the 4th J hat. And let's add a newtons per coulomb there, just so we know. And that is the component form of the electric field at point 2.